The purpose of this video is to remind you of some power rules you learned in Algebra 1, to show you the origin of a couple of those power rules, and then to introduce you to a new power rule that you're going to need to know. So I'm not going to bother explaining the background behind these three rules, because those three rules are the ones that everybody tends to know really well. When you multiply things that have the same base, you add the exponents. When you divide things that have the same base, you subtract the exponents. And when you raise a base that's to a power to another power, you multiply those exponents, always keeping the bases the same. These two rules that are in blue, though, I want to talk really briefly about where they come from. The first is that anything to the 0 power is 1 except for 0. If I were talking about something to the 0 power, let's not write that first. Let's write this. Now, one of the ways of thinking of the number 1 is that it's anything divided by itself, right? So if I wrote any like x to the n divided by x to the n, that would give me something that when I use the exponent rule on this one, x to the n minus n, and that would give you x to the 0. That's why x to the 0 equals 1, and it's also why that's not true when x equals 0, because that would cause you to divide by 0 here. Likewise, the negative exponent rule, if I wrote 1 over x to the n, 1, as we just showed from this rule, is the same thing as x to the 0. And then if I used this subtraction rule again, I would get x to the 0 minus n, which is x to the negative n. So that's where these two rules come from. But those are ones that we talked about earlier this year, and you probably should already know. Now, there is a new rule that I want to talk about, and it's what happens when you have a fractional power. So, for the purpose of that, I will tell you that a fractional power by the way, another way of saying fractional power is rational exponent. And I will tell you that a fractional power is synonymous with a radical. Now, another way of saying a radical is a root. And we have several types of roots: square roots, cube roots, fourth roots. Now, the question is, how are they connected? So I'm going to sort of guide you through how they're connected. A square root of x. When I say the square root of x, I mean something that when I multiply it by itself, I get x, right? That's what a square root means. If I had written a cube root, it would be the cube root of x times the cube root of x times the cube root. Ooh, that's bad. Of x equals x. And I could do another one for the fourth root. I think you understand how that would look. Now, I'm telling you that a fractional power is representative of a radical of some sort. So if I wanted to figure out what the power was that represents a square root, I could write x to some power. I don't know what that power is, but whatever it is, I would be multiplying it by the same thing, because square root of x times square root of x. And that would give me x to the first. Now, when you multiply things that have the same base, you add the exponents. So this would end up being x to the question mark plus question mark, which would be 2 times question mark. Now, if these two things are going to be equal, the bases are equal, so the powers would also have to be equal. And that tells me that that power that represents a square root is 1/2. So square root of x is the same thing as x to the 1/2. Now, if I were trying to figure out what the cube root of x was as a power, I'll write that up here this time, make it a little more sense. I'm trying to figure out what that is, so I would do the same replacement I'd add those exponents together, so I'd have 3 of those question marks. And then 3 times the question mark would equal 1. So the question mark would equal 1/3. So you see a square root of x is 1/2. A cube root of x is 1/3. Sorry, x to the 1/3. That's really sloppy, but I think you get the meaning. So the fourth root of x would be x to the 1/4. So basically, any nth root of x is x to the 1 over n. So that describes at least some fractional exponents, ones with 1 on top. So what happens when you have a number that's not 1 on top? Well, if I had x to the 2/3, for instance, I could think of 2/3 as 2 times 1/3, right? Now, we have a rule for multiplying exponents, and it's this rule. But we're used to thinking of it going this way. I want to think of it going this way. So I have two things that are multiplied. I'm going to write it in this form. And then the 1/3 power means, from the rule we just used, the cube root. So this is the cube root of x squared. Now, I could also think of x to the 2/3 as x to the 1/3 times 2, right? I mean, 2 times 1/3 and 1/3 times 2 are the same, right? Because multiplication is commutative. So if I were to then write this as x to the 1/3 raised to the second, using this rule over here, that would give me the cube root of x squared. So if I have a fractional exponent, and I want to write it as a radical, there's two ways of doing that. I can either write it as the nth root of x to the m, or I can write it as the nth root of x all to the m. And either of those is perfectly fine. So this is the new rule for powers that we're going to need to know. So I want to give you like 3 problems to try your own. I'd like you to change these to radical form. X to the 2/3, y to the 5/2, and z to the, well, let's just do those two. And then I'd like you to convert these to exponents. And that would be the 7th root of x to the 11th and the square root of x to the 10th. Not 10th. Let's make it the 13th. All right, so you can pause the video and then come back and see if you got them right. Okay, so x to the 2/3, you'd use the rule that we wrote, which is this. So I could write x to the 2/3 as the cube root of x squared, or I could write it as the cube root of x squared. And no matter which way you did it, that would be okay. The square root, sorry, y to the 5/2 would be the square root of x to the 5th. Now, when we had talked about square roots before, you've never had to write this number here that indicates the type of radical it is. That's called an index. And if you have a radical that doesn't have an index written out, it's implied that it's a square root. So I can actually write this without the index, and that would represent a square root. I can't do that with any other kind of root. Now, one word of warning. I've written this in radical form, but because this is in radical form, it's not in fully simplified form, because I've got a square root and I have 5 of the same factor on the inside, like that. So I could pull out an x and an x at this radical. So the fully simplified radical form would be x squared times the square root of x. I didn't have to do that here because a cube root calls for trios of the same factor and only had 2 x's on the inside. By the way, you can think of this, but this is an improper fraction. Anytime you have an improper fraction and you write it as in the radical form, you're going to have to simplify something out. It's sort of like turning it into a mixed number. This would have been 2 and 1/2, and if you look out here, we have x to the 2nd and then x to the 1/2. So if I convert this into exponent form, this is actually very straightforward. The radical's index goes in the bottom of a fraction, and the power here goes in the top. So down here, this would be 13, and remember, if there's no index there, it's implied that it's a 2. Now, the homework that you'll be given is going to be combining this new rule with rules that you've already learned. So let me give you an example of problems just so you can see it. Okay, so this problem has coefficients, it has fractional exponents, it has negative exponents, it has dividing, it has multiplying. So we're gonna have to figure out what to do with all this stuff. All right, so my first suggestion when you're doing this is to realize that this 4x to the 2/3, the only thing that's being raised to the 2/3 is the x. Same thing down here on the bottom. So the first thing I like to do is to write it where the coefficient gets separated from those. Now, the 4 would be included in the power if there were parentheses around the 4x, right? All right, so I've separated everything. Now, we talked about rational expressions before, right, and how you could simplify them. We have a common factor here between these two numbers. So I'm going to go ahead and simplify that. Now, I'm also going to divide the things in the fraction that can be divided together. So I have these two things, which are both x's, these two things, which are both y's. They have common bases, so I can use those power rules for division that we talked about before. So this would be 2 times x to the 2/3 minus 1/2, and this would be y to the negative 1/4 minus negative 1/3. So when I go to simplify that, I need a common denominator for 2/3 and 1/2. That would be 6. So that's 4/6 minus 3/6, which is 1/6. And the y, the common denominator between 4 and 3 would be 12. So that would be negative 3 plus 4, so it's 1/12. So this would be the answer in simplest rational exponent form. If I wanted to write that in simplest radical form, because the numerators are both 1s, I could write the 1 there, I could leave it off. It would look like that. Now we're going to talk about a little later how to write these in one radical, but for now, this will suffice.